Good evening. Today we are going to be seeing about version control systems. So this document should give you a small overview of what is going to be, what we are going to see today. And this is not going to take a lot of time like the previous one. So yeah, version control. What is version control and why do we need it? So version control systems are used when you are working on a large project and there are a lot of people who are contributing to the project. Say for instance, take the Linux kernel project. So as you all know, Linux kernel is open source and it is main and then literally everyone can contribute to the Linux kernel project, and if your code is good enough it will be accepted. So how do you manage too many people working on the same code, too many people who are contributing to the same project? How do you manage the ensure that one person's changes are also reflected in the other person? Say you and I work on a project, I make a change, and once I made a change I should tell you that I have made a change and I should send the code over to you so that you can start working on that change also. So how does this happen? It is easier when you do it in a single office where you can put all your files on a network drive and then share it. What if you're working on teams which are geographically large, far apart, and you also and it is not feasible for you to share code every single time? So that's where version control systems came in. Also, version control systems are named because it will let you choose to go back to the versions that were working properly. For instance, you release a particular version of an app and then you decide to make an update to it, and somehow it screws things up. What do? You go back to the earlier version. So how is that possible? Only if you have taken a backup of the previous version's code you can do that. Instead of taking backups of every single version of the code and every single change, you can have it in a version control system which will manage all these things for you. So it actually makes a developer's lives easier. So what are the different ways to achieve this version control systems? There's something called SVN, Mercurial, and Git. So SVN, Mercurial are a little bit outdated these days, and they are not at all not used anymore unless until it's for legacy projects. And JIT or Git or however you like to pronounce it. It was developed by Linus Torvalds himself, and it actually was an alternative to Mercurial and SVN. So Git protocol uses a specialized Linux command called git, and it is pretty simple to use. So what git does is it creates a working tree from your directory. So I'll draw the basic structure of git protocol. Say I have a directory called I have a directory called my project. My project is my directory name, and I have some files in it called a.java, b.java, c.java, whatever, c.java, d.java, etc. So when I initialize this Git, when I tell this Git protocol to use this project as as the repository, actually there are certain things that you should understand before we go in. So basically, Git works on a distributed computing model. So you'll be having a centralized code server called a repository, in which the cloud, which is present in the cloud, in which you can host all your code, which is a centralized database of all your code. And a lot of people can connect to that centralized repository and they can add information onto that. And they can also retrieve information from that. So that's how Git basically works. So the centralized thing is called the remote, and your local thing is called the um, and your local devices are called the clients or local branch, etc. So there is a single repository. A project is called a repository here, and a single repository will be shared by all the clients and the remote. So basically, you will be having a copy of the repository on the remote and on the local side as well. So consider that my project here is the repository, and you have 4 Java files in that. You want to tell Git to use that as a you want to tell Git that this is my repository. You can start initialization and do help me do version control. So what Git initially does is it creates a tree. So it creates a tree, and it manages to give me a minute. I'll just draw the tree and show it to you. I seem to have forgotten the tool. It's called the draw tool or something. Where is this tool? Oh my God. Okay, I'll just use pixel art. So basically what we'll do is we'll be having a root node here, that is your project, and you'll be having a single main branch called the master. So where is the text here? So this branch will be called master, and this branch is called the master, and you'll be having all the files stored in this master. So these 4 Java files that you had will be tracked by this master branch. So initially this is the repository structure. This does not look like a tree, I agree, but still your repository will consist of a single branch called master, and all your files which are to be tracked by this repository will be stored as different nodes of a branch. So what happens when you after you initialize, you push this code. I'm going to use technical terms here. You push this code, that is send this code from your local onto your cloud. So after you send it to the cloud, someone else creates a copy of this. A copy here is called the clone. A copy of a repository is called a clone. So what will happen is on that person's system, the entire project will be recreated again. So this is the basic structure of how Git works. And so single branch projects will work well when you have a small team and a small project to manage. Say you have a very large project and you're going for the version 2 or version 3 of a single project. So my version 1 code, that is, I'm going to use technical terms here, production and development. Production is the code that is running currently, that is available to all your users, and development is the code that you're building on as upgrade process. So your code is now successfully running, and now you want to make changes to that. So what is the most possible, proper way to do that? You don't edit your source code directly, that is the code that works properly. You don't edit it. You create a new branch, name it something else, and you add whatever you want to that branch. So basically what will happen is a branch will be created from master and your code will be added onto that. So I'm going to call this branch as a development branch. So this can be called dev. So the dev branch will contain code that is also in master, and will also have code that you have started to type new. So this is how the basic of Git works. You can add any number of branches or any number of, or you can add how much ever files you want, etc. So this is the basic storage structure. I'm going to tell you how to create a repository, how to initialize it, how to commit, push, fetch, sync, etc. And then we'll be done. So how do you create a repository? I'm going to use GitHub for this. So GitHub, you go to GitHub, login, and here there'll be plus create new repository. And I'm going to name this repository as a GitHub sample. And if you want a description, you can. And if you want to make it private, you can, but that will be a paid option. So I'm going to just public, and I'm creating a repository. So GitHub basically teaches you how to use this. So if you want to create a new repository, you type git init first. So I have created a new folder on my local system. I'm going to share you that. So this is the GitHub sample folder. I'm going to type git init, and an np initial repository will be initialized. Now I should be telling the Git repository that where my remote is located at. That is, where is the server? Where should all the code go? So I'll type git remote as origin, and I'm going to type the code that is given by the GitHub, which is here. Git at github.com/teachinmy7/github. So I'm going to just copy paste that code. I'm just copy pasting that. So I'm just copy pasting that, and that's it. The remote has been added. Now I need to create some files, add them onto the tree, and then send them to the repository. So how I'm going to do that? I'm just going to type vi a.txt. Just going to type some random stuff in that. So this is the random code. So I'm going to add this onto the repository. So git add a.txt. So I'm going to add this file alone onto my GitHub tree. So this tree, as I told you earlier, this command will make the addition to the master branch. So here a.txt will be added. Okay. So next what I'm going to do is I'm going to commit this change. So commit is something like we have confirmed this change. So if you want to commit is akin to saving a project. So if you want to save something, you want to have a reference point to go back to, you commit. So remember that before sending to the server, you have to commit, or else the changes won't be sent to the server. So once you're sure of what you've done, you're sending it to the server. So before sending it, you're saving it on the local, telling that, hey, this is a checkpoint. You reach a checkpoint, and then you're sending. So I'm just telling initialization. That's what I've done here. So initial -m is for message. Initialization. So it'll tell that one file has been changed. There are 5 insertions, etc. And then I'm going to push this onto the git push origin. Origin is my remote. That's what I name my remote. And the branch I want to push it in is master. So git push origin and master. It will take a bit time. Once it's done, you'll be able to see it on the GitHub website. It's still loading. I'll just give it a minute. So initially I have to add the RSA fingerprint, etc. Oh, permission denied public key. I'm sorry, I seem to have messed it up a bit. I'll just change the thing. In order to fix this, you can just Google the error and fix it off. You just change this. I'm lazy now, I can't do that. Let's paste this. This is control O. Right again. It will work now. I used SSH and I didn't add my key onto the GitHub website. That was the error that occurred. So you can easily fix it, but that's a process. So you need to do 3 to 4 lines. So I'm just going to ask me something. So it as you can see, the output is new branch of master to master. So it has pushed the master from my local to the master of the origin. I'm going to refresh this page, and you can see that a.text is here. Once I click it, you can see whatever I've typed there. Okay, so next what I'm going to do is I'm going to teach you. I've taught you how to initialize, how to commit, how to push. What is pull? Pull is something when someone else works on your repository and you want to sync all those changes onto yours. So I'm going to just edit this file on the cloud. So basically any change that is on the cloud should be reflected onto your local. So that is called pull. So you pull data from the cloud onto your local machine. I'm going to add a line here and I'm just telling the commit as blah 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 and commit. So that's it. It has committed. Now I'm going to type git pull. I'm going to pull it from origin. What branch do I want? I want the master branch to be pulled. Right here. It's going to ask me my password again. If you use SSH, it will never ask that. So it will just ask you once. That's it. It's done. See, it's fast forwarded. That is no other change. It can easily do it for quickly, and it has fetched. So now, if I open my a.text, you see the changes that I made in this. So you see that I've added that DSG blah 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 line, and it's here. Okay. So that's how you pull from a repository. How do you create a new branch, and why do you need to create a new branch? So a new branch is usually created when you are starting to work on a new feature or when you want to create a new version. So say you are working on a web app and you need to have another, and the code from the repository is actually running on your website. So you want to change something in that code without affecting the users of your website. So how do you do that? You create another branch. So how do you create a branch? Hit checkout -d. You can create -d for a new branch, and you're going to create a branch name as test, and it has switched to the new branch. So if you want to see what's the branch you're on, type git branch, and you can see that you're on test. So the branch that I've created here is so this test is derived from master. I'm going to create a new file on the test branch and I'm going to push it. So how do I do that? I'm just going to createvad.text and typing user. So you can see that I have two files. I'm going to commit again. Git commit -m created a branch. So as you can see, I didn't add that file. So I'm going to add git add d.text, or if you want to add all the files, just put git add dot. I'm going to create the file now. Git push origin. What is the branch that I created? Yes. Git push origin. Sorry. This is a tiny little command that I have which will correct all my errors. So there it is. Alright, it's going to ask for my password now. And how will be done. Still waiting for this. And it's going to push it onto the branch now. Yeah, so I refresh it again. Go into the repository and refresh it. So going on to the repository here, you can see on the master branch, you can see the branch here you can see there's only a.txt, and on, if you click the branch, you can see the test branch, and on the test branch you can see that I have two. So why did it happen? Why did the second file, I mean, why did the second file come in test? As I told you, the second branch, that is the test branch, was derived from master. So the test branch will have a.txt as well as d.txt. So as both of them are from master, we'll be having both the files on this branch. And there it is. Okay. So a.txt and d.txt are on this branch. So if I create another branch, it will be creating another one more. I mean, whatever is on the second branch, I mean, all branches are created only from master. So whatever is on the master will be reflected on the other branches as well. All right. Next, fetch. So fetch is something that is used when you want to get something from the cloud repository. So if you want to fetch something, say you have a new branch, and I'm going to create a new branch on this cloud console, web console, and I'm going to, so I'm creating a new branch here. How do I create a new branch? I use GitHub so far. So, all right, I'll figure out a way. On branch, you create a new branch here, and you ask and you fetch it from the local. So fetching is something getting from the server. So how do I create a new branch? So I think I should edit a file. So I'll add a new file and naming it as new, and I'm creating a new branch, and I'm calling it as fetch example. So I'm doing this to create an example. So I've done this. All right. So I'm on code. So there are three branches here: master, test, and fetch example. So how do I bring this fetch example onto my local repository? I'm going to tell git fetch. So it will see the scan the master, I mean the central repository for any changes, and it will download whatever changes. So it's going to ask my password. Right. And see, as you can see that it has fetched the, I mean it has got the fetch example branch from here. So if I type git branch, I'll be on test. So if I want to switch it to the git fetch example, I just need to type git checkout fetch example. I have switched to a new branch. So if I type git branch again, you can see that I'm on fetch example branch. All right. So that's how fetch works. And sync is when you have two branches. Like sync is mostly used in very high complicated versions, in which you want to make sure that the two branches are exactly same before you want to work on it. So I can just type git sync, and sync is not a command actually. So git sync is something that is unique, and I guess you can check it out here. I'm not going to do anything over there. I just want to tell you how this works. So if I click here, I can merge and then sync it with this production branch. So that's how it works. So I don't want to do that here because it might mess up whatever I'm working on right now. So all right, sync. So what is merge? Merge is something when you want to combine two branches together. You don't want two different branches and you just want one branch. So I'm going to type git merge master, and I want to merge test and master. So you're writing test into this. You have to type a commit message here. So I'm just typing and writing down git branch. You can see that. Okay, and now I need to commit and put this in this. this. I don't need to commit actually. Just git push. So I'm going to ask for my password, email and password again. I think so. Not too sure how it behaves in this method. Exactly. Application filter. I made a mistake in my password, I guess. So it has committed. So that's how merge works. Then we're going to see about clone. What is clone? Clone is basically creating a copy of someone's repository onto yours. So I'm going to take another repository of myself. I have this called emergency buddy, and you can see that there is a link here. So anything that is public will have a link. So you can copy this. I'll just take from this guy itself. So he has a, I don't know who he is or why he has Sith. So Star Wars time. So there's something called Sith. I'm going to copy this. Just copying this and moving out of this. I'm going to clone. So I'm going to basically create a copy of whatever he has created onto my local machine. So git clone, pressing that. And if you want to create a new directory, if you want to move all these files onto a new directory, I can create it carefully as Sith clone. And it will clone it into Sith clone. I copy all those files. You can see there are 4 folders and 1 readme file. Once it's done, I'll be able to show you all those 4 folders have been copied and there's a zip file. Oh, it's counting all the objects. There are around 5,884 files on this, and he has 2 branches. So it's going to take a while, I guess, around 15 to 18, 20 MB. So all those files will be downloaded onto my system. All right. So what is a merge conflict? A merge conflict is something that occurs when too many people or more than one person edits a file. So say you have a login screen, and you and I work on the same login screen again. So I commit first, push it onto the cloud repository, and then someone else also works on the same file, and they push it. They also work on the same file, and when they try to push, you will be getting something called a merge conflict. So what is a merge conflict? Merge conflict is something that happens when both of you work on the same file, and your changes won't be incorporated before I make the change. So what will happen is it will be causing some errors in your program because multiple lines will be edited. So I'll show you some code here, which is an example of a merge conflict. Not a clear example, but still this is how it works. This is in the production level application. As you can see, all those lines in red were changed by some other guy, and the lines in white were changed by me. So what happens is all these lines in red will be marked with an identifier and a unique identifier along with the, so it will be starting like this, head, and along with the commit ID. So there will be a commit ID which is a hexadecimal notation, and it will end like this. So whatever changes are done in this commit will be put up here. So if I type, hi, my name is Arun in that commit, it will be mentioned here, and you type something like, yeah, this another commit. Someone else type, hi, my name is Darth Vader. So this will be here. So the person who's going to pull the file from the cloud repository will see both of these, and he has to take the decision which one to keep, which version is proper and which version he has to keep. So this is the only place where you have manual work to sort out the corrections. So I don't want to keep my name. I'm going to keep Darth Vader. So I'll just delete this off, and this is what will remain in the file. I need two people to demonstrate a merge conflict. So I haven't done that live here. So as you can see, the clone has been completed, and I'm going to cd into that directory, cd zip clone, and you can see that there are 4 folders and 1 file. So an exact replica of whatever is here in this folder has come here. So that's it about Git. There's a lot more to learn in Git. So if you want to learn more, go to Code Academy, and you'll be having browser bouncing up. Code Academy has a new course on GitHub, which will let you learn a lot. So learn Git on Code Academy. So this will teach you Git in a very easier way, and it's fun as well. So I've tested it out personally, so it'll be easy. Alright, so that's it. Thanks for watching.